Just wait for the last couple of folks to sit down. We get back to our offices and we do some analysis. We write up those analyses, we make recommendations, and then hopefully they agree with our recommendations and engage with us further where we deliver a solution. I am not the sort of person that thrives on a challenge. I don't go into an organization hoping for a bold new project. I really come in and I say, what I want to do is just make a nice, simple Alfresco implementation. I want to have an Alfresco document management solution. I want to have a nice open source stack with a Linux operating system and maybe a Postgres or some other open source database and a nice, hefty enterprise storage area network with a fiber channel to get my content and metadata delivered quickly. And I'll have a happy client. I'll get my assessment done quickly and my implementation done. I'll be in and out really quickly. And it never works out that way. The first thing that I usually encounter is that my preferred operating system of choice is not the client's preferred operating system of choice, but that's not a problem. It's an equally supported platform. I'm familiar with working on both, and everything goes just fine. but then I talk to them and I learn additional requirements start streaming in. It turns out that they don't already have the content in electronic format. It's in a paper format, or maybe they have faxes coming in. But that's okay. I know how to deal with that. I wrote the book on that. And so we'll make them a nice FSoft solution. We'll integrate that. And then I keep talking and I learn more requirements. They've got a line of business application that they're not going to get away from. They have to continue to use that in parallel, but that's, we can work with that. FSoft can export directly to that line of business application, which unfortunately often has a completely different database from a different vendor. Perhaps we can use Alfresco as a point of integration to smooth things out. And the more I talk, the more I learn problems with my nice, simple, easy world. I think John Powell was just saying in his keynote address that there's always a SharePoint installation, and you're not going to kick it out of the enterprise. You need to learn to work with it. And now my happy client is just a client, because he's working now with 2 enterprise content management systems, not just one. And 2 is a low number of content management systems. I think if you heard Ryan McVeigh present yesterday, we engage with clients like the city and county of Denver that have, I think it was double digits, like 11 or 13 different content management systems, let alone all their other line of business applications. And the line of business applications are not always co-located. Of course, they have field offices. And the more I talk, the more I have to go to the whiteboard. And the situation just keeps getting worse and worse the more I engage with my client. And my point is this, that in my personal experience, when you do Enterprise Alfresco, when you do an ECM implementation, you're going to wind up doing a lot of systems integration. And anything that you can do to facilitate that really lets you, 1, provide a better implementation for your client, and 2, lets you focus on the things that you want to focus on, your business implementation, focus on your Alfresco, on your content management needs, and not on the nuts and bolts of wiring these things together. So I've called out a few benefits of using an enterprise service bus, using content management interoperability standards. But these are obviously not the complete list, but they're some of the benefits that I'll be demonstrating today. You get to decouple your applications so they don't have awareness and configuration details about each other. You can orchestrate, you can use the service layer to orchestrate communication so you don't have to wire to a whole bunch of different things. You don't have to implement logic in each of your applications about which things should be talking to which other things. The service bus, that you can implement that at the service bus layer. And additionally, you can really speed things along. You can reduce the amount of time you spend performing those integrations. So I'm going to assume that most of you folks are familiar with the content management interoperability standard API, but it's very important. So if you're not familiar with it, I'm just going to cover it really quickly. The CMIS is an open standard definition for a programming interface to perform common ECM operations, like checking a document, change its metadata, download its content, and so forth. Version 1.0 of the CMIS standard was established in May of 2010. It's been available in Alfresco since version 3.3. And it's effectively 2 APIs from a programmer's point of view. It defines a REST binding, a RESTful binding for web service interaction with your content repository, as well as a SOAP-based binding. You don't have, in most cases, you're not required to work at that protocol level. There are native language libraries that perform this for you and let you make native language calls in Java, in .NET, in PHP, in Python. And there is, as G mentioned in his portion of the iOS, the Alfresco SDK, the mobile SDK, the chemistry, the Objective C implementation of this library is also has been approved by Apache and will be appearing as part of this toolkit as well. So the benefit of CMIS it should be obvious to any of you who are used to developing. It used to be the case before CMIS existed that a vendor like Effisoft, in implementing their scanning solution, would have to implement drivers, modules, to support each product that they wanted to export to. With CMIS, they can simply write a single exporter, and then every product that implements the CMIS protocol will automatically be supported. Of course, not every content repository supports the protocol. Most of the major players do right now, but Murphy's Law says whenever I get at a client, there's going to be some product that does not support the protocol that you need to integrate with. And for those vendors, Effisoft, of course, has to implement custom exporters, or they support an API that lets you write your own exporter. So that's all I wanted really to cover about CMIS. I'm guessing, show of hands, are most of you already familiar with the CMIS protocol, or was that sort of new to you guys? Some of you are familiar, some are not. If you have more questions about that, if I went over it too quickly, I'm going to give some examples of where it gets used, so you'll have an example of that. If you're not and you want to learn more, you can come ask me after. You can also talk to G. You can talk to Ryan at the Zia booth after. We can talk about that a lot more. So I'm going to talk about enterprise service buses a little bit in the abstract. I'm going to talk about Mule a little bit more specifically, and then we'll get on to to the actual case study. An enterprise service bus is a middleware alternative to point-to-point integration. Instead of hardwiring application A to application B, you can implement a connection from your application A to a service bus, and then have the service bus forward communication through to the application B, to the other application that you want to do. Obviously, if there's only two applications, that doesn't provide a lot of benefit beyond the decoupling. Certainly doesn't merit it just on its own. But in addition to that decoupling, that abstraction that performs, there's a bunch of manipulations that you can perform while these messages are being translated. You can transform and translate that message. So if application A communicates in an XML format and application B is expecting a CSV, you can perform that translation. You can compress the content. You can encrypt it. You can perform all kinds of transformations on that content while it's being sent along. You can filter the content. Perhaps you don't want the content to go every time from application A to application B. With simple configuration, you can define criteria for when the information should get there, and that information doesn't have to be hard-coded into your application A in my hand gesturing case right now. You can aggregate messages. If you've got multiple products that are communicating to the service bus, you can have the service bus aggregate those messages or batch them and then send them along to the receiving application as would be appropriate for that usage. And then finally, one of the things that we've found in practice is it's really handy to have a trace of all that content, so that when your communication goes haywire, you've got a log of all the interactions between all your systems, and you can figure out, I can see that you know this system got the content or the message before this system, or they came out of order, or some system didn't get the message. The tracing capabilities are very useful, and obviously beyond the simple benefits of the abstraction and the ability to transform and manipulate those messages, it's of tremendous benefit that all your communications are platform and language agnostic. So it doesn't matter that one application might be a .NET application and speaking in an XML dialect, and then the other one might be a Windows or a Unix-based system. Doesn't matter. All these things can interoperate. And lastly, I should mention that this technology is mature and stable. The concept of ESBs has only been around for 10 years, but Mule was one of the first products in that space. It was established in 2003 as an open source product, and MuleSoft has extended and refactored the code ever since and provides commercial support, which most enterprises are going to require. So before I get into the actual case study, let me talk about a hypothetical example that may or may not closely resemble an actual client that I'm engaged with right now. And so this is the way that this hypothetical financial company's 13-year-old architecture is set up. It's a financial organization, and they have a lot of, it's a scanning solution. It's sort of the origin of the huge bulk of their content. And they've got a Quark-based scanning solution that's no longer supported. Quark has decided they don't want to be in this business anymore. As I described for Ethisoft in my example, if CMIS didn't exist, and it didn't when this thing was set up, they had to write specific drivers to export to every one of their business applications. So there is built-in code in this system that exports to a couple of pieces of custom code and a couple of pieces of off-the-shelf software. There's AnyDoc, which is an intelligent character recognition piece of software. There's Life70, which is specific to life and annuity policy management. And so they've got these specific codes that conditionally figure out when the export needs to happen, translates the scanned content into the appropriate formats, and sends it to each of these 4 things. And then AnyDoc, when it's done processing, making its character recognition process, they've got a batch job at the tail end of that thing that looks at the output of that and then updates various systems with their content. And it's obviously a lot more complicated than this, but I'm using this as an example to demonstrate what an ESB in the middle would look like in this particular hypothetical example. So this is the way that they could have configured things, and if they did, then if they had organized things this way, then what they'd be allowed to do is they'd implement connectors for each of these different systems. Hopefully, in the present world, a lot of these systems would support a CMIS standard, and you wouldn't actually have to make proprietary drivers. But if that's not the case, if it's a repository database that doesn't support the CMIS standard, or if it's 13 years ago and CMIS doesn't exist, like is the case in this hypothetical example, then the ESB supports APIs that let you implement custom connectors for each one of these things. And so it's not actually saving you work in that you still have to write those connectors, but you've got the abstraction layer so that if you decide that you want to swap out your vendors, as they want to do, it's simply a matter of rewriting one connector rather than having to write all of these exporters. And additionally, we don't have to have this additional piece of software that goes and sends the information back to the business software applications. The AnyDoc application can just send the information back to the service bus, and the service bus can do what service buses do best, determine where to route that exported content and send it back to the repositories. So you wind up with a much cleaner architecture. You wind up with some decoupling, and you saved yourself some work. So that demonstrates 2 of the things. And what about that ease of work? Where does that come in? How does this get easier? Because really, it seems like it's just as much work. I just reorganized things a little bit. And where the ease of integration comes in is with all the connectors and message processors and all the tools that come out of the box with MuleSoft. So Mule comes with connectors that let you perform web service integrations, like a RESTful connection or a SOAP-based connection. It contains connectors to access the file system. It contains connectors that let you talk to enterprise systems like SAP or PeopleSoft. There are connectors to talk to cloud-based systems like LinkedIn and Twitter. And if you don't find one that you like, you can implement a custom connector. It's a very simple API. You can implement your own connector, but in large part, if you're dealing with a known piece of software, a really widely used piece of software, there's a very good chance that MuleSoft or they're a partner of ours, and they're who I'm going to use in this case study. But it doesn't have to be MuleSoft. In most ESBs, this is one of the things that you should get from the ESB are these connectors and these message processors. the message processors. So what do the message processors, what do you do with your messages when they go back and forth? With simple configuration, invoking particular processors, you can choose to filter your content. I gave some examples before of sending, you might want to conditionally route information to one application or another application based on certain criteria. Or you might want to choose not to route the information at all and just drop it based on certain criteria. And that also gets to the ability to route the information maybe to multiple applications. And you can transform it. You can encrypt it. You can compress it. You can do XML transformations. You can convert them to entirely different formats. And most of these operations can just be done with simple XML-based configuration. And when I get to the case study, I'll actually show you what that XML configuration looks like to wire up a couple of connectors and then process a message. Once again, you can implement your own custom message processors, and I will give an example of what it looks like to implement a custom message processor. It's a very simple one. I'll drop down to the Java level for just a minute, and then come back up to XML, and then continue to talk just sort of in more of a case study type high level. So let's get to that case study. Zia recently completed an engagement for the USDA. For those of you in Europe here who might not be familiar with the USDA, it's the US Department of Agriculture, and it's the US federal department responsible for policy concerning farming, agriculture, and food. One division of the USDA is the Natural Resources Conservation Service, and the NRCS provides private landowners, usually farmers, technical assistance with restoring, protecting, and conserving the natural resources on their property. They might help mitigate soil erosion, for example, or identify and help mitigate the source of water contamination. The Conservation Delivery Streamlining Initiative within is a project within the NRCS to streamline their operations. They want to get their agents to spend more time in the field and less time doing paperwork in the office. Speaking of paper, they really are a paper-centric organization currently. They're moving away from it. A lot of their current systems operate electronically, but they've still got file cabinets and file cabinets full of manila folders. And the manila folders have a tab, and on the tab is a farmer's name. And inside that folder, they have documents which are perhaps a map of the farmer's land. They'll have some photographs of some sort of problem, some sort of issue with the property, of an erosion issue or some kind of grassland problem. And they'll have a plan that has been recommended by the USDA, a written plan saying here's how you can mitigate that problem. All these things will be in that folder. And what they want to do is, one, get that content electronic, and then two, they want the tab on the electronic folder not to be client-specific. They want it to be land-centric, because the problems that they solve are not problems with the client. They're problems with the land. So they may need to say, I see you've got soil erosion here, and it's the fault of some drainage issue on an adjoining property. So you need to be able to perform geospatial queries and say, I need to get the content for other properties in the vicinity of this farmer's property. And as I said, they really want to get their agents spending more time in the field. The CDSI project, the Streamlining Initiative project, is typical in some ways of other large organizations that we've done solutions for. They have thousands of users, which is not uncommon in an enterprise. The size of their content database is not unusual. They have terabytes of content. The number of field offices is a little bit unusual, but it didn't cause us a specific problem for our implementation, other than for migration, which I actually won't be talking about. But they have hundreds of field offices because their agents are very closely tied to the land. So they spend a lot of time actually going and visit the clients and investigating the the problems with the land. So their offices are in almost every rural county of the United States. So they have hundreds of offices. One requirement of the project is all the assets in the repository must have geolocation information associated with the documents, because they want to be able to perform these geospatial queries of the documents. They have a custom user interface. The end user will not be using the Alfresco user interface. Only the system administrators will use that. They have a custom user interface implemented using Silverlight. If you're not familiar with Silverlight, it's Microsoft's sort of alternative to Flash. So it results in a very nice end user experience. But they're not using anything out of the box with Alfresco for the UI. And then finally, I should mention that this is third generation software, which is usually a red flag when you go into, so this project will be the third implementation of this product. They had a set of software that their field agents used 15 years ago, then they rewrote it, and then 7 years ago they had the second generation software, and we're coming in to do the third implementation of this. I'm making up the numbers, but it's something along those lines in terms of the history. And that's usually an immediate sign that there's going to be a lot of legacy applications. With an organization the size of the USDA, you're not going to come in and start from scratch and rewrite everything from the get-go. You're going to have to go and work with all of these legacy applications that have been integrated with in the past. You're going to have to also integrate with them, and they're going to have old protocols that you're just going to have to work with. So that was indeed a factor of the project. So this is a simplified version of the architecture that we implemented for the USDA. So we have the web-based user interface on the front using Internet Explorer. They're sort of a Windows shop, so most of the folks are going to have IE as their desktop web browsing application. The application itself is implemented in Silverlight, and it's going to make RESTful web service calls to the service bus. The service bus will then contain the logic about which applications need to get invoked. Obviously Alfresco is the content repository, or I wouldn't be here presenting at this conference. And they do have, as I like to see, a good solid storage array network with fiber channel access to the repository and to the database. And then they've got all these other systems that are not going to go away. They've got this NPAD database that contains information about the geographical features, the fields, the fences, the streams, the ponds, and it also contains the information about the issues, whether there's erosion or water contamination, what have you. That database contains that information. They've got SCIMS database is their database that contains client information. They've got a separate database for authentication, which is really information not about the clients, but the end users of the system, the field agents. And then they've got, as I said, a huge number of legacy systems that are all integrated using this service bus, including like Z roles to include, that indicates what the roles are for these users once we've authenticated them, what responsibilities, what operations they're supposed to perform in the application. And so what I'm going to do right now is describe to you just one integration path from Silverlight asking for a document from the repository and sending it back up through the ESB. It's obviously not the most complicated thing that I could show. I mean, but it'll give you enough of a sense for what the configuration looks like so that if you choose to implement Mule, you'll get some sense for what the configuration would be. And I think it'll be pretty obvious how you would then, what it would look like to go and configure up some more complicated scenarios. So here's an interaction diagram that's showing this simple scenario. The user is going to request a document of the user interface. The user interface will turn around and make a RESTful web service call to the service bus. The RESTful web service call will have the document ID on the URL. And then the service bus will turn around and make a CMIS call to Alfresco, and Alfresco does its magic back here. Once Alfresco has the document and is ready to stream it back, it'll send a binary stream back to the ESB, and the ESB will turn around and stream that back to the user interface, where the document can be displayed to the user or saved to disk or whatever operation the user wants to perform. So what do we need to implement this in Mule? We're going to need to implement an inbound endpoint for the user interface. It's going to need a port to connect. The user interface is going to need a port to connect to it, Mule, and it's going to need to know the host name and such. Mule's going to need an outbound connector. It's going to need to know where Alfresco is in order to connect to Alfresco. And then we're going to need to implement a custom processor, because the Mule chemistry CMIS, the Mule CMIS connector uses the chemistry library in its implementation. And so when you do the get content stream call from the Mule connector, it's just a simple XML configuration. You say do a get content stream. You're going to see it in a second. What you get back on the message in your message in the ESB is actually a chemistry object called content stream. And Mule doesn't know how to operate out of the box with a chemistry content stream object, but Mule does know what to do with an input stream object. So what we need to do is we need to go into the chemistry content stream object, find the input stream object, hand it to Mule, and say, here's your content. And Mule can then go and extract the content and send it off to the user interface layer. If you are not comfortable with XML, things are going to get a little bit awkward for the next 5 or 10 minutes. It'll go quickly, and I'll come back up and talk a little bit about some gotchas after I describe what the configuration looks like. I hope this is readable by you guys. This is a simplified version of the Mule configuration. Of course, as with any XML, there's usually a bunch of XML cruft at the top that contains your XML schemas and such, but I've stripped that out for the purpose of simplifying things. Also, in our actual implementation, we didn't just have one configuration file. We had one master configuration file that imports a bunch of different sub-configuration files. And this allows our developers to work in parallel without having merge conflicts whenever they pull in each other's work. So what did I say the first thing we needed to do was? That was to define an inbound endpoint for this for the user interface to connect to. And this is what this looks like inside Mule. You just make a simple XML reference to HTTP inbound endpoint, and then you give it the address that the endpoint that should be defined for the inbound endpoint. So we just say whatever host this service bus is running on open up port 8080 and accept HTTP connections, and there you go. That defines this part of the connection. That allows the user interface to connect to the service bus. The next part of that is to say, well, what are the various calls that you can make to that inbound endpoint? So we can define a RESTful router, so something that listens on that endpoint for a RESTful web service call. And so if a RESTful request is made of a GET request that matches this URI, then here's the code that's going to handle that. And the URI has a sort of templatized version of the URI that's going to get requested. The actual, as I said, the document ID is actually going to get passed in on the URI in a RESTful manner. So that's this part of the interaction diagram right here. The URIs that you'll notice don't match between my diagram and the configuration code. I apologize for that. The next step is now that we've made the connection and then specified this particular URI, is what do we do in response to that? Well, so what's going to happen is we're going to make a CMIS call. We're going to say CMIS get content stream, and then we're going to pass the Alfresco node ref of the document that we want to stream back. The assumption here is that at some point previously in the user interface, we requested a list of documents, and they selected one from a menu somewhere or something. And then this syntax right here is some Mule-specific syntax that says, hey, go find the variable document UUID. And this RESTful router actually defined the variable based on this template when it matched this URI. It defines that variable, and then you can reference that later on in your configuration file. And so that's how you request a particular document. So that's this invocation right here. Now, you might have noticed that I sort of glossed over one aspect, and there's a big blank spot in the top of my configuration file. So how does it know where to connect to? And there's a bit of configuration information that I glossed over. So I'll come back here and show you that it's pretty simple to define where your CMIS file, where your CMIS repository is, your Alfresco repository in this case. And so you give it the URL, you specify the URI for the service document for your RESTful implementation of CMIS, and you can specify the host and the port. And these are actually using the Spring notation for substituting in the parameters, so you don't have to hard code that information. You can have a properties file somewhere external to your Mule configuration for the host and port, and that lets you swap out properties files and have the same Mule configuration, but have different host to host for production, for QA and such, for your dev environment. So that's a pretty simple configuration step. Now, the last step here is the custom processor that I was talking about. So in the course of this flow, we get the content stream, and now sitting on what's called the payload of the message that gets sent back and forth is represented as much like HTTP. There's a message, and then there are properties associated with it, headers. So what's sitting in the body of the message and the payload of the message is a chemistry content stream object. And so as I was saying, we need to find the input stream object that's referenced within the CMIS content stream object, extract that, and then stick that in the payload so that Mule knows what to do with it. So that's what needs to happen right here. So we've got this, we've got the response back from CMIS at that point, and we need to do a little bit of manipulation of the message in order for the document to get back out. So here's what it looks like. I put the entire class in here without the import statements and such, but I just wanted to emphasize so you could see that it's a really simple API. You just you get something that processes a Mule event and then throws a Mule exception if something goes wrong. So this can perform all kinds of manipulations to the content, and the bulk of it is really just 2 lines of code. So here you can see we're taking the event, which was the argument to the single point API call. We're getting the message from that event, and then we're getting the payload object, and we're saying it's a content stream. So we're saying we're effectively casting it to be a content stream object. That's the chemistry object. Mule doesn't know anything about chemistry out of the box, other than we actually configured this Mule CMIS connector in. And so what we need to do is go to the content stream, and so we get stream. So that thing contains a Java IO input stream object, which is something that Mule does know how to deal with. We slap that thing in the payload, and automatically Mule, when it finishes processing the message, is going to stream that back to the user interface. So that completes the implementation. Voila, we're done. I, of course, perhaps oversimplified things a little bit. One of the problems that we have at this point is that the user interface has a bunch of binary data, but it doesn't know what to do with it. It doesn't know whether it's got a PDF or whether it's got a JPEG image or a Word doc. It doesn't know what it is that it's doing, so it doesn't know what sort of operations to allow the user. And similarly, it doesn't know the file name. So even if it wants to just write the thing to disk, it doesn't know what file name to use in writing the thing to disk. So I'm going to take my simple example and make it slightly less simple to accommodate that. Just show you a slightly more complicated configuration base. And then I'll pop out of the configuration end of things. So what I'm going to do to handle this particular problem that we have is make two CMIS calls. The first call will be one that gets the object by ID. That's going to have the metadata associated with it. That metadata is going to get returned in an XML format to Mule. Mule's chemistry layer is going to take the XML data and create a content object, a document object, Java POJO representation of that XML. And then I will call the content stream, make this a content stream CMIS call, and return back the binary document, and also associate the MIME type and file name. Those will get sent along on the HTTP header, so that which is pretty typical for a RESTful call, so that the user interface application will know what to do with that document, what the document type is, what its file name is, and so forth. So what I've done is I'm showing right here, we're going to do two calls. This lower call is the call that we were doing before, the get content stream object. But we need now to perform a call first. We're going to get the object by ID to get its metadata. And that maps to the two calls that I'm showing here on the interaction diagram. So here is the call to get object by ID. It looks just like the other call that we did before, but what it puts on the payload is a Java object that represents the document with all its metadata. And what we did was implement a custom transformer. And this custom transformer just takes the payload, knows that you've got a CMIS object on here, and says, please just convert that to JSON. I'm not going to show the Java for this. You've sort of already seen the Java for what a transformer looks like. But you can imagine that it's pretty straightforward. It just takes the object, iterates through all the properties associated with the CMIS object, and then defines a JSON string to represent that object. If you're familiar with JSON, it's not a lot of string manipulation to build that out. Here is where, so you can see this is just the reference to a transformer, and up here is where the actual transformer is referenced. There's the class name for the transformer that you're implementing. And again, you've already seen what the API for these things looks like. It's really straightforward. So why did I bother transforming this thing from a CMIS object to JSON? The answer is Mule knows how to manipulate JSON right out of the box. So I can now just use this Mule-specific syntax. You can sort of guess. There's a pluggable syntax that lets you handle all kinds of different formats. If it doesn't, if you've got some kind of format that's particular to yours, you could register a new expression handling syntax. But we just decided the easiest thing to do was to write one piece of reusable code and use it all over the place, and then we can just pull it out by just making sort of an XPath style JSON syntax extractor. So what we do is we say, hey, we've got this JSON representation of a CMIS object on our body. Go find the content stream MIME type and slap that in a message property. As I mentioned, the messages have the payload and then these properties that are associated with it. So I'm just extracting this particular piece of information out of the body, and I'm putting it as a property of the message. Same thing with the name of the document. Taking it out of the body, out of the JSON in the body, and writing it to a property. So now I've gotten the metadata, I've gotten it back in an XML format, and I've done a little manipulation to store that information in the headers, so that when I make my next invocation and the content stream object gets written on the body, I haven't stomped and lost the information that I wrote. So the next thing I do is call the content stream before, do that custom processor that I showed you before. Just grade those out because that's all the existing stuff. But what do I do after this? What I do is now I look at the response content type, and I look at the variable file name that I went and saved off in the header, message property headers. And I build a content disposition string using another kind of evaluator. And again, this is Mule specific. If you just go look in the reference documentation, they'll list out all the out-of-the-box expression handlers. And then I save these in. If you're familiar with the HTTP protocol, you'll recognize the headers for the content type and content disposition. When I save those properties, the RESTful handler will automatically go and put those properties on the response object. Oops, wrong direction. So now I've got everything set up here, ready to send back to the user interface. And that completes the round trip. Now, when the information streams its way out of Alfresco, we not only have the binary data, but we've got the MIME type and the file name, content disposition, there ready for use by the user interface layer. So that's a quick example. I'm done with the XML and Java stuff for now. That completes sort of what the configuration looks like. I want to give 3 examples of little gotchas that we encountered when we were in the course of doing the implementation. The first gotcha we encountered was that was the geolocation implementation. As I said, there's a requirement that all the content has to be geolocated, tagged with geolocation information. And the USDA was particularly excited to use version 4.0 of Alfresco because they knew that version 4.0 of Alfresco came with Solar, and that Solar implements geospatial queries. Unfortunately, in Alfresco 4.0, the version of Solar that ships with Alfresco 4.0 did not support the geospatial queries. It was an earlier version of Solar. And even if it was the right version of Solar, Alfresco hadn't yet implemented the ability to translate those queries and support them. So what do we do? They need to perform these geospatial queries as part of the implementation. And so we had a couple of different options. One option was to leverage the fact that they've got SQL Server databases with a lot of this information already in there. And SQL Server does support geospatial queries. So one option was to actually perform the geospatial queries against SQL Server and then get the content, do a query against the Alfresco repository and then do sort of like a programmatic join. And hopefully you're all cringing when I say the words programmatic join. That's a very inefficient approach. The other alternative that we came up with was to do a faux geospatial query just using bounds checking, using latitude and longitude properties on the documents themselves. And this doesn't allow you to do proper geospatial queries, but you can get kind of a bounding box and approximate a geospatial query. We talked with the client, and the USDA said, that's going to suffice for us for our needs as long as you come up with a sufficient size bounding box. It'll get the documents we need, and if it's slightly outside of the region, we can ignore those results. It's not that big of a deal for our end users. So that was the solution, was to actually not do a proper geospatial query, but to do range-based queries in our Lucene, and then use Mule to hide the elegant workaround to encapsulate that, so that in the future, when Alfresco and Solar support this protocol, we can just make a simple change and get proper geospatial queries implemented for them, and return a much better result set for them with no impact to any of the other systems in their solution. What was the next problem we encountered? Was with the CMIS connector. There were some bugs in the CMIS connector for Mule that we encountered. For instance, there was a session management error that prevented Mule from starting if the endpoint wasn't there. If Alfresco wasn't running, the CMIS connector would fail in such a manner that Mule wouldn't even boot, which was a pretty drastic problem with the driver. Additionally, it didn't support aspects, and it didn't support multi-value properties. Aspect support is sort of not surprising because that's unique to Alfresco, somewhat unique to Alfresco. So what's the solution for that? Well, the beauty of working with open source software is that Mule provides the source code for this connector on GitHub. So it was really easy for us to go, when we hit our first glitch saying, holy cow, the thing doesn't even boot, what's going on? We go and look, and it's not a tremendous amount of code. It's pretty obvious to us what the problem is. We're able to just check it out, make a quick fix, and get that in there. Similarly, we were able to implement the aspect support. Implementing support for aspects is something that Alfresco has already done for us, so we just need to make some simple configuration changes to the way that the Mule CMIS connector is configured. We've got support for aspects, and then we decided to make an additional extension to allow the Mule CMIS connector to be able to specify multi-valued properties. We have we made all those changes, distributed that, redeployed the CMIS connector, and everything's fixed. So that's one of the big wins for open source. In addition to open protocols, the open source really lets you work around some problems in the field. And then lastly, we had some problems with CMIS and with Alfresco's implementation of CMIS. In the CMIS protocol, there's no way to just lock a document. There's no API endpoint defined for that. There's no method for that. And with Alfresco's implementation of CMIS, we had a problem where we'd queried the version history, and we'd get back a document ID, but then when we'd go and say, well, get me the content for that version, it would give us back the head. And it turns out that the version IDs that were returned weren't useful for us in being able to retrieve the specific version of the document. So what do we do? Well, one answer would be Alfresco's open source, and we can go fix Alfresco to implement to go fix that bug. A much simpler solution for us was to use the fact that Alfresco provides this really easy capability to surface web-based API calls. We implemented our own web script, and I'm guessing if you've done any Alfresco configuration, you're familiar with web script development. If you're not, come see us at the booth, and we can talk to you about it. But it's a really core feature of Alfresco, and they use it internally to communicate from their share layer to the database layer and to expose all sorts of services. So we just wrote a custom web script that said, lock this document, take an ID, or to perform a version history request, or to perform an operation on a specific version of a document. We made a few web scripts to implement the problems, the features that were missing, or the features that were buggy. And then it's a simple matter in Mule of, instead of making a CMIS call, just define an HTTP outbound endpoint and invoke that web script instead of making a CMIS call. That gets me through the specifics of the case study. I'm going to talk really briefly about what the future holds for the technologies that I was talking about, and then I'll open it up to some questions. First of all, I want to talk about CMIS. What's the future for CMIS? CMIS will support secondary object types in version 1.1. And this will make it so that we won't need to do the customization that we had to do in the future to support the Alfresco-specific configuration. So that'll support aspects without having to do any additional configuration. There is going to be a third API implementation. Remember I mentioned that it does SOAP and RESTful APIs. There's going to be a JSON-based browser binding, which will be even more lightweight and more performant, and it's really suitable for use in browsers if you're doing sort of Web 2.0 AJAX-y type call, or in the mobile applications, for instance, in implementing the iPhone application. This would be perfect. A third feature is bulk updates, so that you can perform one API call and update lots of documents at once. Again, a big performance win. So CMIS 1.1 has a lot of exciting new features. This is, there are actually, I think, 8 major new features. I only called out a few of them. If you want to hear more about other new features coming in CMIS, please come to the booth, talk to myself, talk to Ryan McVeigh, talk to G. Lee. I can tell you all about that stuff. I want to briefly mention what the future is for Mule. They're very excited. They're, of course, going into the cloud. They are offering a cloud-based service for their offering, just straight-up service-based offering called Cloud Hub. It's just a cloud-based version of what they've got available on-premise. But additionally, what they want to do is package these things called IAPs. And Zia is working with Mule to actually develop IAPs, which are not just Mule, but Mule and a set of applications all packaged together, pre-configured to run together. And the first IAP that Zia and Mule have developed jointly is one to implement a accounting solution. It implements scanning application with Effisoft. It implements a cloud-based implementation of Intact. It takes Alfresco, uses MuleSoft to orchestrate communication between them, and it's available. You can purchase this accounting solution from Zia or from Mule and get a single and just get the entire solution all packaged up, already for you, all in a cloud-based solution. And this is where Mule really wants to go in the future, is start doing packaged solutions like that. And lastly, I just want to mention that we're going to be making more changes to the Mule CMIS connector. The changes that we made, we didn't just sit on them. We contributed them back to the community. They've been adopted back into actually just last night, I think. They got adopted back into the Mule, Mule connector project. And we're going to be making some more improvements to that connector. If you want, keep an eye on Zia's GitHub account. You can see those changes as we commit them, and hopefully we'll offer those back to the community as well. I'm wrapping things up. I just want to, in conclusion, hope that you guys see some of the benefits of a service-oriented architecture, of open source, and of ESBs in conjunction with Alfresco to make a really powerful, loosely coupled, strong architecture with an ease of implementation. And I want to emphasize a little bit of self-advertisement, how involved Zia is actively in these areas. We're not just consumers of these technologies. We are driving the new features both in the standards and in implementing features. And go talk to Phil if you want to know more about IAPs. Phil Robinson out in at our booth is happy to talk to you guys about these package solutions offered. The entire solution all at once. That's it. Stop by our booth. Go download the CMIS connector. Go buy our book. If you're interested in the book, learning more about scanning solutions, we have discount codes available. Stop by the booth, grab the little piece of paper. It's got the discount code written on the back, and we can get that for you. With that said, I'm done. If you have any questions, please feel free to ask now. I think we're slightly over. Should I just, do you want to take questions, or should I just send them to the booth? Okay, so if you have questions for me, just come up and find me personally after this, or I'll be heading back to the booth after. So you can talk to me there. Thank you very much.